Okay, welcome back to step 1994, question number 2. Compared to question 1, this question is I would say ridiculously quite simple. Even though, there is still bits to it and there's areas you can make mistakes, right? I mean, everyone makes mistakes. It doesn't require it just requires you to understand sort of how to differentiate things. And it's sort of, if I were to just sort of say at its simplest what the problem is, it's just differentiating things, right? I mean, that's really what it is, right? So all you have to do is differentiate things, and you need to know how to differentiate some standard functions like ln of x and stuff, but it really doesn't require much beyond that, I'll be honest with you. So the last question is a lot more demanding, right? If I go back up, you can see all these sort of diagrams you have to draw, all of that. But for this question, you just got to differentiate, man. So again, I think you probably should be careful about which questions you start off with. I don't know. I doubt that people. I doubt that the advice would be to do these in order, but I'm not 100% sure. So, yeah, I definitely would have started with number 2. It's gonna get me sort of feeling a little bit more confident in myself. I think question 1 I would have started panicking. Okay. Anyway, so we have to just differentiate the following. So first of all, I guess if we have f of x equals x to the power of a, then this is just a simple power rule. So f prime of x is equal to a times x to the a minus 1, right? So for example, if I give you x to the power of 4 is equal to y, then dy dx is equal to 4x cubed, right? Simple as that, right? This is my a, so that's the case where a is equal to 4. So I'll write here, a equals 4. So that's simple enough, right? Okay, so I guess let's move on to II. So then we need to differentiate a to the x. This is also relatively standard, but I guess we can derive it. So if we have y is equal to a to the x, and you ln both sides, you get ln y is equal to ln of a to the x. So ln y is equal to x ln a. Now I can differentiate both sides. This is involving some implicit differentiation here, which I assume they expect you to know. So when you differentiate both sides, you're going to get 1 divided by y multiplied by dy dx, right? Because it's like a chain rule, because we don't know how y changes with x. We don't know what the derivative of y is, but it's a function of x, right? So if we want to take the derivative of this side with respect to x, it's like a chain rule. So we have to do the derivative of ln of something is just 1 over that something. Then you have to multiply it by the derivative of whatever's inside, because that's not known to us, right? Then you just take the derivative of stuff on the left-hand side. That's just going to be equal to ln of a, since this is just like a linear term, right? It's like having 4x. The derivative of that is just going to be 4. So then we multiply both sides by y. So this implies that dy dx is equal to y ln a. Now we can go back and see that y is equal to a to the x. So this is equal to a to the x ln of a. As required. Okay, I guess we can just keep moving along here. Then for the next question, we are asked to differentiate x to the x. Very similar reasoning here. So if I let that equal y, then I have that ln of y is equal to x ln of x. Differentiate both sides, so I get 1 over y times dy dx is equal to ln x add, so that's going to be x. So this is just me using the product rule, by the way. So I'm differentiating the x on the left-hand side of that product to give me just 1 times ln x. Add x times 1 over x, it just gives you 1. So you're going to get 1 over y dy dx equals ln x plus 1. So therefore, dy dx is equal to ln x plus 1 in brackets multiplied by y. And we know that y is x to the x, so that's just equal to x to the x multiplied by ln of x plus 1. Okay, very nice. So moving forward, I guess. What about number 4? So we have this time sort of x to the power of x to the power of x. So kind of like a power tower here. And we'll get, again, but the method is exactly the same. You should be a little bit more careful with it, because you can make some silly errors in this. So if I just ln both sides, I get ln y is equal to ln of x to the power of x to the power of x, which is just equal to x to the power of x, ln of x, right? So now I can ln both sides again, so I get ln of y is equal to ln of x to the x, ln x, which you can split up to be equal to ln of x to the x add ln of x. So yeah, make sure, don't forget about that ln of x, because you might accidentally split up and just forget about it. You might write plus ln of x, right? But no, it does have to be ln of x, right? Because you multiply both the things that are inside here and put them into one log, so it does have to be ln of x. Okay, and that's equal to ln of y. So now we can differentiate both sides, right? So when I differentiate both sides, what am I going to get? So I'm going to get 1 over ln of y, right? So we treat ln of y as one thing first. So we're going to do 1 over that, 1 over everything inside the log, multiplied by whatever the ddx is of ln y. That's just the chain rule. And then on the right hand side, well, ln of x to the x is just x ln x, and the derivative of x ln x. So let me just write this over here. This is just equal to x ln x add ln of x. Well, x ln x, sort of the derivative of that is just ln x add 1 from before. Derivative of ln of x, well, that's kind of similar to ln of y, except it's a little bit easier because x is not a function of anything. It's what we're differentiating with respect to. So it's our independent variable. So when I differentiate this, but it's still chain rule, so I have to do 1 over ln of x multiplied by ddx of ln of x, which is just 1 over x. So this just gives me, if I can sort of move down on the page, that just gives me ln x plus 1 add 1 over x ln x, right? Because ddx ln x is just 1 over x, so you're going to do 1 over x times 1 over ln x, which just gives you 1 over x ln x. Okay, so then we have that, so we have that 1 over ln y times ddx of ln y is equal to all that. So that just gives us ln x add 1 over x ln x, and then you can just effectively, well, first of all, we know what this is, the derivative with respect to x of ln of y. That's just what we were dealing with earlier, right? It's just the chain rule. So that's just going to be multiplied by 1 over everything inside the log, so 1 over y, multiplied by the derivative of whatever's inside that log, so dy dx, right? Which we don't know, because y is a function of x. So then we have the ln of x plus 1, add 1 over x ln x, and then what we can do is we can now multiply both sides by y ln y. So we have therefore that dy dx is equal to y ln of y multiplied by ln of x plus 1 over x ln x. Now y is x to the x to the x. So this just gives us x to the power of x to the power of x multiplied by ln x to the x to the x, which is just x to the x ln x, right? Since effectively what I'm saying is that ln of x to the x to the x, right, is just equal to x to the x ln x, right? That's just power rule. You're bringing the power down to the front. Okay, so then we have that, and then we just multiply that by ln x, add 1 over x ln x. So that's the answer, but let me just simplify that even more, right? ln x, we can multiply that through these brackets. We can multiply sort of ln x, sort of distribute it through this bracket. So then what we're going to get is just x to the power of x to the power of x times x to the power of x times ln of x all squared, add ln of x, add ln x over x ln x, which just gives you 1 over x. So that's the answer to sort of IV. Let me try and color these in so that it's very clear what I'm trying to say. So let me just color in II, IV, II, I. And now we have one more part to do, so we need to do v. And v asked us to differentiate x to the x times x to the x, I guess, so x to the x times x to the x times x to the x different times, which is different to the one above that, right? Because that's x to the power of x to the power of x. So that's you doing x times x times x all the way sort of x to the x times. So that was IV. But for v, this time we're trying to differentiate x to the x, right, to the x. But so x to the x first to the x. So that's x to the x times x to the x times x to the x. That's just you just doing that x times. So effectively, each time that we do this, we're going to be adding an x, right? So we're going to be doing, so x to the x times x to the x. By indices, well, it's just x to the 2x. And so on and so forth. But if we're doing it x times, it's going to be x to the x times x, right? So that's just going to give us x to the x squared. So effectively, we're asked to differentiate, in this case, x to the power of x squared. So this is just equal to y, which is equal to x to the power of x squared. So if I do ln of y, we get the same trick. We get x squared ln x by the power rule. So ln of x to the x squared, you can just bring the x squared down to the front. And then we differentiate, right? So then you can differentiate both sides. So 1 over y multiplied by the derivative and the thing in derivative of y, which we don't know with respect to x, is equal to the derivative of the stuff on the right. So that's 2x ln x. So that's just me using the product rule, plus x squared over x, so just plus x. Then we multiply everything by y. So this just gives us at the end dy dx is equal to y multiplied by 2x ln x plus x. And y in this case is x to the x squared. So that just gives us x to the x squared multiplied by 2x ln x add x as our final answer. Okay, very nice.